Welcome students to another lecture on a real analysis, in which we shall show that the function f of x equal to cos square of x is uniformly continuous on R. First we discuss the definition of uniform continuity. A function f of x is said to be uniformly continuous on an interval I if for all x y belongs to this interval I, if x minus y mod is less than delta, then f of x minus f of y is less than epsilon, where delta and epsilon are any positive real number. Now we use this definition to prove that the function f of x equal to cos square of x is uniformly continuous on R. First we take two elements from R. For this, let x1 and x2 are two elements from R, and R can be written as this is equal to the interval minus infinity to plus infinity, such that the condition is x1 minus x2 mod is less than delta, and this is our equation number 1. Now in each question we start like this. First we take x1 minus x2 mod less than delta. Now we try to establish a relation between delta and epsilon. For this we take modulus value of f of x1 minus f of x2 as f of x minus f of y mod should be less than epsilon. Now f of x is cos square of x1. Now cos square of x1 minus cos square of x2, that is cos square of x1 minus cos square of x2 whole mod. This can be written as cos x1 minus cos x2 mod into cos x1 plus cos x2 mod. We use the relation that mod of AB is equal to mod of A into mod of B, and secondly we use the formula a square minus b square is equal to a plus b into a minus b. Now students, we simplify this right hand side and try to establish a relation between delta and epsilon. Now we have two other relations, that is cos x1 minus cos x2 can be written as this is equal to minus 2 times sin x1 plus x2 by 2 and sin x1 minus x2 by 2. Similarly, we have a relation for cos x1 plus cos x2, which this is our modulus value. Similarly, for cos x1 plus cos x2 we have 2 times cos x1 plus x2 by 2 and to cos x1 minus x2 by 2 whole mod. Now students, again we use property of mod as mod of AB is equal to mod of A mod of B. By using this property we can write it as 2 and 2 gives us 4 and mod of minus 2 is plus 2, so this gives us 4 times sine x1 plus x2 by 2 mod sine x1 minus x2 by 2 mod. Similarly, cos x1 plus x2 by 2 mod into cos x1 minus x2 by 2 whole mod, and the reason is this property of mod. Now student, we have some another relations, as we need to establish a relation between delta and epsilon, and we know that x1 minus x2 mod is less than delta. We need a relation between delta and epsilon. For this we need here a term in which x1 minus x2 appears as a factor. Now we have different relations for trigonometric functions. Now the relations are, first we have as sin x mod is less than or equal to x, we have one relation. This we have another relation that sin x mod is less than or equal to 1. Similarly, cos x mod is less than or equal to 1. Now whenever we deal with the question of trigonometric functions, we use these relations according to the situation. As situation demands that we need a factor x1 minus x2, so this trigonometric function sin x1 minus x2 can give us a factor x1 minus x2 if we use this relation that sin x mod is less than or equal to x. For rest of the identities we use this inequalities that sin x mod is less than or equal to 1 and cos x mod is less than or equal to 1. Now this is less than or equal to 4 times sin. Remember students, whatever the argument is, formula remains same, that sin x mod is less than 1. If we take sin 1 upon x, this is also less than 1. So argument can be any number, x1 plus x2 by 2, x1 minus x2 by 2. Relation, this formula satisfies for all the argument values. So sin x1 plus x2 mod is less than or equal to 1. Now for second function we use the relation sin x mod is less than or equal to x, and x is equal to x1 minus x2 by 2. The argument is x1 minus x2 by 2, and the reason is this relation that sin x mod is less than or equal to x. Now for the rest of the identities we use cos x mod is less than or equal to 1, and again cos x mod is less than or equal to 1. Now we have used all of 3 identities. Now students, we can write it as this is equal to 2 times, as 2 and 4 cancel out, 2 times x1 minus x2 whole mod. This is our modulus value, 2 times x1 minus x2 mod. And from equation 1, as we know that x1 minus x2 mod is less than delta. Now by using equation 1 we can write it as this is less than 2 times delta. The reason is x1 minus x2 mod is less than delta. Now if we choose epsilon is equal to 2 delta, then delta is equal to epsilon by 2. Now if we use this value of delta, we get a relation in term of epsilon, that is, on the left hand side we have the function cos square of x1 minus cos square of x2, which implies cos square of x1 minus cos square of x2 whole mod. This is less than 2 times, as value of delta is epsilon by 2. Here 2 cancels out, and we have cos square x1 minus cos square x2 whole mod is less than epsilon. Now for any epsilon greater than 0, we have a delta greater than 0 such that whenever x1 minus x2 mod is less than delta, then cos square of x1 minus cos square of x2 mod is less than epsilon, and this holds for all values x1 x2 belongs to R. And this is the definition of uniform continuity, which implies the function f of x is equal to cos square of x is uniformly continuous on R. Thank you very much for watching this video lecture, and don't forget to subscribe my YouTube channel.